In this video, we're going to learn some tips that will probably make integration problems a whole lot easier, especially when you have to deal with integration by parts problems. So most of the time, most of the case, integration by parts problems consist of two different kinds of functions, such as fx or gx. And let's say fx is logarithmic function and gx is polynomial function. At this point, here comes the most amazing acronym, LATE. L stands for logarithmic functions, A stands for algebraic functions or polynomial functions, and T stands for trigonometric functions, E stands for exponential functions. So as you go left, you want to take the derivative of the functions, and as you go right, you want to take the antiderivative of the functions. So here's logarithmic function and polynomial function. Because logarithmic function is on the left compared to polynomial function, so you want to take the derivative of the logarithmic function here. So here is the tabular method. You just write diff or d, whatever you want, on the left, and you just write I or integrate on the right, and you just write the corresponding functions such as fx, gx, and you just take derivative over and over again until it becomes 0, and you just take the antiderivative over and over again, and you connect those two with the sign of plus minus. Okay, that's it. So I'm pretty sure you're now like, what the hell is he talking about? So let's just solve some example problems. I'll show you how to do it. So here's the first example. Get the antiderivative of x times cosine x. So you just write late here, and this is algebraic function, and here is trigonometric function. So A is on the left, so you want to take derivative of x, and you want to take the antiderivative of cosine x. So you just write d here and I here. You just write x and cosine x. What are you going to do? You just take derivative of x until it becomes 0. So derivative it, and that's it. And you just take antiderivative of cosine x, which is sine x, and minus cosine x. You just connect those two, plus, connect those two, minus. That's it. X sine x, minus becomes plus cosine x, plus constant. Simple as it. Alright, let's solve the second problem. Get the antiderivative of x squared times exponential x dx. And again, you write late. This is algebraic function, this is exponential function. Because a is on the left side, you want to take the derivative of x squared. So again, d I x squared exponential x, and you just take derivative of x squared until it becomes 0 to 0. And if you take the antiderivative of exponential x, it just becomes the same, right? Exponential x. You just connect those two, connect those two, connect those two. Total sign, plus minus plus. That's it. 0 x minus 2x ex plus 2ex plus c. Okay, let's solve the third problem. This is getting trickier, so please focus. So get the antiderivative of x times log x. So again, late. This one is algebraic function, this one is logarithmic function. So logarithmic function is on the left. You want to take the derivative of logarithmic function. So di log x x, and you just take derivative of it. So 1 over x, and you just take antiderivative of it. And here's 1 over x. If you just take derivative of log x, it becomes 1 over x, and it also becomes minus 1 over x squared, and so on. It never becomes 0. So at this point, what I want you to do is just connect those two with plus, connect those two with minus. And so since you haven't done the process, you haven't finished the process, so this becomes minus antiderivative of x 1 over x times 1 over 2x squared dx. So that's it. Like this becomes 1 over 2x squared log x. What is this? This one becomes 1 over 2x, and it's simple, right? Minus 1 over 4x squared plus constant. Okay, so let's go to the fourth problem. Get the antiderivative of x squared log x dx. So simple. LATE, this one is algebraic function, this one is logarithm function. So you want to take derivative of logarithmic function. So you just write di again. Here you write log x, here x squared. So again, 1 over x. You don't wanna take derivative of 1 over x over and over again because it never becomes 0. So again, antiderivative of this. So you just connect this 2 with plus, connect this 2 with minus, but this time also antiderivative of minus antiderivative of, multiply those two, 1 over 3 x squared dx. So the answer is 1 over 3 x squared log x and minus 1 over 9 x squared plus constant. Okay, all right, finally the last example will probably be the hardest one, but you can do this. All right, come on. Get the antiderivative of ex times cosine x dx. So here you got exponential function and trigonometric function, LATE. So t is on the left side, so di, you write cosine x exponential x. So you take derivative of this, minus sine x ex. So I'm pretty sure it never becomes 0, but I will keep doing it. I will tell you why. And you just connect those two with plus, connect those two with minus, and connect those two with plus. Then you got ex cosine x minus ex sine x. Also this one becomes minus integral ex cosine x dx. So minus integral ex cosine x dx. So you just move this to the left side and divide it by 2. So ex cosine x dx is 1 over 2 ex cosine x minus sine x. So this one is a little trickier, right? So why did I stop here? So let's say you just stop here. So you don't want to take derivative or antiderivative of ex. So let's just say you had stopped here. So it becomes nothing. Like this one becomes ex cosine x dx, and you just connect those two, right, with plus, it becomes antiderivative of ex cosine x. It's just trivial. It doesn't mean anything, right? So let's say you stopped just here. So you connect those two and you connect those two. And what does it become? It becomes ex cosine x, and it was plus and minus. Minus becomes plus ex sine x dx. It doesn't mean anything either because we don't know what it is. So that's why I stopped here, to get the minus of what we want. So if you have minus of what we want on the right side and what we want on the left side, you can get what you want, right? So you can just move this to the left side and get what you want. Alright, that's it for today. Thanks for watching. If you like this video, please hit the like button and subscribe to my channel. I will do more of these videos every week, so please hit the notification button as well and leave comments down below. Okay, I hope to see you on the next video.